A with that, no.
Imagine you get a couple of cigarettes.
I'm a nerd.
How would you like to be on FW?
So we're trying to, so in algebra 2 and in term pre-cal, we're gonna use rationalize sometimes. A lot of time we got radical in denominator, and that's not okay. So you cannot have a radical in denominator. So, so here's one thing I'm saying. So if you have something like 4 over square root of 2, okay? So here's a problem that you cannot have that radical in denominator. We know that, right? In algebra 2. Do we learn something like this? Nicole, you move to there, so you don't have to hide behind the camera. Okay, so you cannot have a radical in denominator. That's just the way it is. So there's got to be a way to have to get rid of this radical. So what we propose is we propose some ideas that can get rid of this radical. So do you have any ideas how do we get over that? Yes.
Can't you like put in parentheses the square root and then like the, I don't know.
Okay, so I like your idea. You say put a parenthesis and just square it. Yeah. Technically we should do that, but we didn't do that. Because if you square it, right? So you say it's 1/2, I can put a parenthesis as square it, that's gonna become 1/4. But 1/4 is not the same thing as 1/2. So you cannot just square something. But what with this one that you just said, but it might have something similar to that. So how do I do that? How do I get rid of this radical? I know you know. Okay.
What do I know?
Yeah, well, that's what she said.
Can you like multiply it by square root?
Multiply by square root 2. There's a difference, right? So, but when she both sides, when she says both sides, I think she meant this. So top and bottom. Because what happened when I multiply by square root 2 over square root 2? What am I multiplying? 1. I multiply a function that we don't know about. We cannot square this. If I square this, I change this function. If I multiply by square root 2 over square root 2, I did not change the functions. Does that make sense? So then you're gonna say that's 4 over square root 2, that's gonna be, now what we're gonna do is multiply this, 4 times square root 2. This is outside, this is inside. So the way you think about multiply a radical is outside by outside, inside by inside. So in this case, it's gonna be 4 square root 2. And on the bottom, it's going to be square root 2 times square root 2, which is square root 4. Or you can know square root 2 times square root 2 is going to give you 2. The radical is going to disappear. And there's a reason why. So that's going to be 4 square root 2 over 2. And I can simplify the outer thing. So this is going to be fraction. So we can simplify that as going to be 2 square root 2. And that's my simplifications. A lot of people that don't see this, you say, oh wow, this is a representation of this. Okay, this is the same representation as this. We just change the way it looks, so we don't have a radical in the denominator. Are we okay? So a lot of people say, well, why is square root 2 times square root 2 is equal to, so the first way to look at it, square root 2 times square root 2 is square root 4, square root 4 is 2. Or there's a second way to look at it is 2 to the 1/2 power, because this is power over roots, that's times 2 to the 1/2. Since they have the same base, the power is going to add. So that's equal to 2 to the 1/2 plus 1/2, which is 2 to the 1 power. That's another way to do it. You need to use this tactic to rationalize something that's more difficult. Luckily, in this class, I'm not going to test you to rationalize the cube root. The cube root is going to be a little bit more difficult for advanced students. Okay, so, but right now we don't need to do that. So, Also another thing, when you multiply radicals, I want you to make sure something. So when I multiply a radical, it's gonna be square root of A times square root of B is equal to square root of A times B. But what's more important is gonna be inside of a radical multiplied by inside, and outside by outside, times outside. So if I have a 3 here, if I have 2 here, then it's gonna be 3 times 2 outside, and the inside is gonna be AB. So inside by inside, outside by outside. Okay, inside by inside, outside by outside. Kind of remember that because that's gonna come back to help you on a lot of things. Now, what do we do next? So we can say, hey, can I simplify this? 2 square root of 6 over, I don't know, let's say it's 4 square root of 8. Can I get rid of that radical on denominator? So what would you propose here? How would I get rid of radical there? See here I multiply the exact same radical as here because I know this radical and this radical will cancel. Yes?
There.
Go ahead.
Square root of 8.
Okay, you can do that. Or we can do 2 square root of 8 or 4 square root of 8, but square root of 8 should be good enough because the idea is just trying to get rid of square root of 8. You don't have to get rid of 4, but oh yeah, also 2 can cancel out, so there's a 2 here, it's kind of silly. So 2 can cancel out. So you can multiply by top and bottom by square root of 8. Okay? So that was a kind of like a silly question, but you can multiply this by square root of 8 times square root of 8. And I can cancel out those 2 and 4, so that's going to give you 2 and 1. Are we okay here? And on the bottom, it's going to be what? 2 times square root of 8 times square root of 8. What happened with square root of 8?
Cancel out.
It will cancel out, becomes
1,
not 1,
8.
just 8. Square root of 8 times square root of 8 is square root of 64. That's going to give me 8. So, or square root of 8 and square root of 8, that's square roots are going to go away, it becomes 1 over 8. So it'll be 2 times 8. On the top, it's going to be square root of 48. And that's equal to 16. But we know how to simplify square root of 48, do we?
That's equal to square root of 16. 5.
Square root of 16 times what?
3.
Times square root of 3, right? Square root of 16 is 4. So it'll be 4 square root of 3 over 16. And this 4 and 16 can simplify down to square root of 3 over 4. That's the answer. Is there any other way to do the same question? Yeah, there's other way to do the same question. Let's show you what can I do here. 2 over 4, square root of 6, square root of 8. Hopefully that doesn't confuse you. This 2 and 4 simplify, right? 1 and 2, right? Right? Also, this is same radical, right? Can I put in 1? You can actually 1/2 square root of 6 and 8. Can I do that? That's just one of the things I can do. It's equal to 1/2 square root of 3 and 4. I don't know if this is shorter, but you still have to rationalize, which is kind of long actually. Maybe this is silly. So that's going to be 2 square root of 3 on the top. 2 times 4 is 8. Cancel out is equal to square root of 3 over 4. It's still the same way. Actually take it longer to do. Maybe not a good idea, but it's also another option. So I want you to try a problem. So let's say if I have a 3 square root of 6 over square root of 8. So I want you to rationalize this. They almost the same question. What do I multiply here?
8.
That's equal to 3, 48 of 8, right? And what is 48?
16.
So it's gonna be 4 times 3 is 12, right? Square root of what? 3, right? And that's simplified down to 3 over 4, no, 3 over 2, square root 3, and that's my final answer. That's how do I rationalize. You okay here?
How do you get from 3 to square root of 48 to 12 to square root of 3?
Okay, so that's a good question, right? 3 square root of 48, that's equal to 3 times square root of 16 times 3. And square root of 16 is 4, 4 times 3 is 12. So it'll be 3 times 4 square root of 3, that's equal to 12 square root of 3. Or you can do the 48, 2, 24, 2, 12, 2, 6, and 2, 3. So this is one group, 2 group. So this one's gonna have one survivor, so it's gonna be 4 square root of 3. But you gotta remember there's 3 in the front, so that's gonna multiply. So this is pretty easy, right? Okay, now we're gonna switch it up a little bit. So what if you have 2 radical on the denominator? Oh, by the way, I want to show you this is some advanced student. You want to think about how to rationalize a cube. It's more trivial. It's not out of time. It's never tested usually. So even me, when I was teacher, I don't remember how to do it. I had to look it up how to do it. So if I have like this, the third root of 6 like this, and you want to rationalize this, this is a much more complicated than this. But there's a way to do it if you want to get rid of this radical. But you have to implement this idea. 2 to the 1/2 times 2 to the 1/2 is equal to 2 to the 1/2 plus 1/2 equal to 2. So what would I multiply here? Well, I will do this. 6 to the 1/3 power. Okay, so this is a harder one. I'm not going to test this. But I'm going to show you. You can rationalize even the cube root, which is a lot harder, but it's not very, very important. So here you can actually simplify this. You can say, okay, I want to get rid of 1/3 because anything you got like a fractions, then I'm going to have radical. So what's a way to get rid of this 1/3?
Adding 2/3.
Yeah. Now this one you don't need to learn. So if you don't worry about what you only worry about what's on the test, it's not going to be on the test. That's just for a student who interested in. So 1/3 plus 2/3 is going to be 1. So that's going to be 6. That's going to be 3. Now that's going to be third roots of 6 squared. So that's equal to the third root of 36 over 6, and can simplify it down to this 3 and 6, simplify it down to 3 root of 36 over 2. And that's my final answer for that. But that one just for advanced students who are interested in mathematics. How do you simplify the cube root? But it's not going to be on the test. I won't put this on the test. Anything else here is going to be on the test. Fair game on the test. Okay. And next thing's definitely going to be on the test here. So, we're going to rationalize those two radicals, adding or subtracting on the bottom. So we're gonna do that. Okay, so this one you have to focus now. This one's really hard. So I'm gonna give you a question like this. It's 2 square root 3, and I'll give you practice questions. And so two square root 3 over 3 square root 2 minus 4 square root 3. This one's hard to rationalize. Okay, so now you got two radicals on the bottom, and there's one radical on the front. But it's okay to have radical on the top, but it's not okay to have radical on the denominator. So what are you supposed to do? Multiply by what?
You subtract them first?
You cannot subtract them because they are not, yeah. So if you think about they selling different things, right? Are they gonna compete with each other? No, they're not. They are selling different stuff. So you cannot add and subtract like that. Now if you got, that's a good question, right? If you have 3 square root of 2 plus 6 square root 2, that is gonna be what? 9 square root 2, right? Now if you have 3 square root 2 plus 4 square root 2 plus 3 square root 3, 7 square root 2, not 10, because this is square root 3, plus 3 square root 3. They're not like radicals. So those things called like radicals. Those are not like terms, but like radicals. So this is a good way to put it. Like radicals.
So it depends on the square root.
Yeah, depending on what's inside, right?
Can you multiply the square root of top and bottom that we did in the last one?
We're not trying to rationalize, we're just trying to simplify this. Okay, so now here, what you propose?
That you multiply the square roots.
Okay, square root. So which one?
2, the 3, and
Wait,
square root of 2.
Can't you put them into the same like house?
No, you cannot, because they are different. 3 square root 2 minus 4 square root 3, they're not the same radicals. You cannot add and subtract. You need to have a like radical for you to add and subtract. So if it is 3 square root 2 and there's 4 square root 2, then you can subtract them. Okay, yes?
Can you do anything with the numerator and the denominator since they have the same radical?
That's what I was about to say.
They have same radical. No, you cannot cancel this way. So for example, if you have 2 over 3 plus 2, those two cannot cancel like this. It's not okay because this plus sign here. So you cannot simplify it that way.
Do you use the bottom first? Since those two radicals are like, can't you multiply the other one that's not related to those two? Like the 3.
Give me an example. Give me an example. What are you supposed to multiply?
Like you multiply 3 square root 2 on the top and bottom.
Okay, 3 square root top on the bottom, but the problem you still have square root 3. You're still not gonna get rid of square root 3. You can get rid of this in temporary, but it's not gonna get rid of this one. So how do we get rid of both at the same time? Yes?
You find a common multiple.
What is common multiple?
Never mind.
Okay, no mind. Okay, but here what we're gonna teach you is actually this thing we keep on talking about it. SAT always have the same thing. It's called difference of a square. Most of you guys don't think about difference of a square, but difference of a square is a big deal. What do I mean by big deal? It's so big deal that every test, at least 2 questions are related to this. Indirectly or directly. So this is called indirectly. So let's assume that this is A. And let's assume that this is B. Okay? But if I multiply by some other term here, which is, we know what is A squared minus B squared is equal to, right? If I factor this, what am I gonna get? No. It's actually A plus B times A minus B. Do you know this?
Yes.
Hopefully, right? When you see what? X squared minus 4, that's equal to x plus 2 and x minus 2, right?
Yeah.
That's the difference of a square, right?
Yes.
Now remember, we driving the car forward, but we never learned how to drive a car backward, right? Remember Fast and Furious?
Yeah.
You had to be able to drive the car backward just as fast as you can drive forward. Because sometimes you have to race backwards. Right? So now we're going to use that as advantage. This is advantage. So we know it's A minus B here. So we multiply here, we multiply by A plus B. It's called conjugate. So conjugate here is going to be, so you start with a minus sign. You're going to multiply, the middle one is exactly opposite. So it's going to be 3 square root of 2 plus 4 square root of 3. And if you do that, for the top and bottom, there's one nice thing we'll do is, guess what? If I multiply this, this is our radical. But at the end, we know it's A squared minus B squared. Square and square root are cancel. They contradict each other. So they actually inverse each other. So then therefore you can get rid of that. So then you say, okay, well, let's do that. And I'm going to show you the long way to do a problem and short way to do a problem. Now we're going to say that's bottom to equal to. On the bottom is 3 square root of 2 times 3 square root of 2. I'm going to do this on the side. So 3 square root of 2 times by 3 square root of 2. That's equal to what? 9 square root of 4. 9 times 2 is equal to 18. It's A squared, right? We know this 2 multiply is going to give you A squared minus B squared. Just figure out A times A is A squared, that's equal to 18. Now here we're going to do what? B, which is 4 square root of 3 times 4 square root of 3. Outside by outside?
16
times 3. So it'll be 18 times minus 48.
Ooh, minus. Oh, that's why.
Now imagine you were to do a harder one. You would just do this 3 square root of 2 minus 4 square root of 3, and you're being not smart. And that's possible because sometimes we don't think about things, and we're just being, oh, this one's 9 times 2 is going to be 9 times 2, and this one's going to be what? 12 square root of 6, right? And you're going to be minus 12 square root of 6, and then you're going to do 4 times 4 is equal to 16 times 3. You see how much hassle this is?
Yes.
Or you could have 18 minus 48, you still get negative 30. So why should you go through that? Well, we know the formula. That's what I call indirectly. Difference of square is always applied all the time. So now we're going to multiply the top. The top is going to distribute. So it's going to be 6 square root what?
6.
6 plus 8 square root of 9. But 8 square root of 9 is 3. So can I just write down 3 here?
Yeah.
I don't have to write another line. So it'll be 6 square root of 6 minus 24 all over minus 30. Now here's what you did math wrong. And here you got 6 square root of 6 minus 24 minus 30. This is a good answer. This, if it's a 5-point question, I'll give you 4 points. But I really need you to get the last points here, because in SAT, you cannot cancel this is 6 and 30 right here. I call it, you kill a panda if you do that. What you're supposed to do is this. You're supposed to split them, because A plus B over C is equal to A over C plus B over C. Because the bottom's one term, you split them. You split them individual. So we can call it split methods. Split. So now we're gonna say that that's splitting, so it'll be 6 square root of 6 over minus 30 minus 24 over, oh, this is plus, right? Sorry, this is plus. So this one is going to be plus 24 over negative 30. Now the 3 and 30 will cancel. 6 and 30 cannot cancel because the inside is radical. So it's going to be square root of 6 over what? 5, negative 5. And this one's going to be negative.
So,
That's 4 over 5, right? So it'll be negative square root of 6 minus 4 all over 5. That's my answer here. And you say, hey, that's done. I know it's a lot of work, I'm gonna ask of you, but we want you to try it, and we want you to be precise, because Monday you'll be gone. Party in the beach, or barbecue somewhere.
Are you gonna do the spirit week then?
I have no spirit. So we're gonna give you a question that says 3 square root of 5 over 2 square root of 3 plus 4 square root of 6, and I want you to simplify this. 3 square root of 5 over 2 square root of 3 plus 4 square root of 6. I need to rationalize this. The answer is behind this board. I need some whiteboards. Oh, by the way, I do plus this time, so do you see that? If I start with a plus, the second is what? You gotta make sure it's conjugate, right? By the way, this is a conjugate, there's a term called conjugate. Conjugate, you might wanna write it down so in case I say what does conjugate mean? Your teacher in the future next year is gonna ask you what's conjugate of this. It's basically if you start with A minus B, you should end up with A plus B. So let's start with the A plus B, you should end up with what?
A minus B.
Yeah. So that's called conjugate. But conjugate is coming from difference of a square. That's why I say indirectly and directly on SAT, they test this all the time. It's annoying, but they do it. They do it. Inside by inside, outside by outside. Yeah, but at 15, you cannot simplify anymore, so you cannot take it outside. They're stuck in there. Whatever is inside the trap house stay inside. They're not coming out. There's no way you can factor out anything there. Unless there was like a 4 in there or a 9 in there, because there's a perfect square. But your work is pretty close. Right now you are still on track. If you got it right, go check. I didn't want to show it to everybody because everybody try it. Today's homework, I'll post the answer again. It's not recording.
Let's look at the time.
How much time I have?
2 minutes.
Everybody done or no? So I did it on this board. I'm gonna go buy some of the small boards so I can work ahead of time. So I start with a conjugate, so it's plus, I'm gonna go with minus, right? So when I multiply the bottom, it's gonna be 2 square root 3 times 2 square root 3, which is 4 times 3 is equal to 12. Okay here? Because that's the difference of a square. And then 4 square root 6 times 4 square root 6 is going to be 16 times 6. So left with 12 minus 96 on the top, on the bottom. On the top is going to be this. And you're going to go all the way down here. The answer is right here. So you can take a picture of this if you want, or you can watch the report of this.
It's probably gonna die. That's a pretty good, you're lucky.
You get it? No.
I got the first 7 steps.
And what happened to the rest?
That's going to be in the video.
Yeah, sure.
Thumbnail and video. That's a good day.